On this slide, we talk about functions. Now, functions are special kind of relations. In the previous slide, we talked about relations, and relations were nothing but subsets of Cartesian products. So, on the previous slide, you should interpret as relation from set A to set B. So, that was our first definition. Now, here we are going to talk about special relations. So, we will just talk about relations with a specific property, and that will become clear as I write the definition. So a relation, we call this relation F. From set P to set Q. From set P to set Q. So in previous slide we talked about relation from set A to set B as a subset of a Cartesian product, and you should think of P to Q in the same way. So a relation F from set P to set Q is called a function. So it is called a function or said to be a function if every element of set P has one and only one image in set Q. So let us draw this relation in the form of a diagram which we showed in the previous slide and understand it. What is this special property? So first I draw set P and then I draw set Q, and then we will describe the relationship between P and Q and say that this relation is a function because it specifies a specific property. So let me enumerate the elements of set P. Say set P consists of P1, P2, P3, P4. Yeah, 4 elements. Okay, let us draw the elements of set Q. So we have Q1, Q2, Q3 and bunch of more elements. So every element in set P has one and only one image in set Q. So P1 is mapped to Q1, say P2 is mapped to Q2, there is only one image of P2, that is Q2. P3 is also mapped to Q2, but P3 has only one image Q2. So see these points P1, P2, P3 are all and P4 are all mapped to one point only. So P2 is mapped to Q2, P3 is also mapped to Q2, but they are mapped to only one point. So each point in set P has only one image in set Q. The image may not be unique, but it has precisely one image. So let us talk about this business of what we call as image and pre-image. So Q1 is image of P1 under F. So under this function F, or we can say under this relation F. So there is precisely one image. Q2 is image of P2 under F. So there is only one image of P2, that is Q2. Similarly, there is only one image of P3, that is Q2. And Q3 is, there is precisely one image of P4. So you can see that a function is one image, one and only one image of every element of set P in set Q. Now let us talk about pre-image. So P1 is pre-image of Q1 under F. So this is just opposite of image. So you can see P1 gets mapped to Q1. Similarly, P2 is pre-image of Q2. But P3 is also pre-image of Q2. And P4 is pre-image of Q3. Now let us describe what is not a function. So you can look up some examples in the previous slide when I described relations and see what relations are not functions. And here we will describe a particular example. So there are two sets, say P and Q or A and B, and there are certain elements in say set Q and there are certain elements in set P. So one element of set P say gets mapped to two elements of set Q. Now this cannot be called as a function. So this is not a function. It is a relation, but it is not a function because one element in set P has two images in set Q. So if you have two or more images in set Q, then you are no longer a function. Now generally we are given implicit functions and we have to do certain tests on them. So the easiest test to do is called the vertical line test. The vertical line test tells us whether a function has a unique image or it has more than one image. So you draw a vertical line on the x-axis. So the function goes from x-axis to the y-axis, and for every value of x you want a unique value in y. Yeah, so that is how it will be a function. For this example, fx is equal to square root of x. Let us draw this. So fx equals to square root of x looks something like this. So if you draw a vertical line, so let me draw a vertical line in blue. So if I draw a vertical line, it cuts at 2 points. One here, second here. So it is not a function. So for every value of x, you should have only one value of y. So we get two values of y here. So it is not a function. So fx equals to square root of x is not a function. But fx equals to x square is a function. So let us see. Again we use a vertical line test. So this test is really easy to perform. So fx equals to x square or y equals to x square is a function. So the graph looks like this. Now if I draw a vertical line anywhere on the x-axis, it will cut the graph only once. So there is one unique image. So the image is not unique because -1 also gets mapped to 1 and 1 also gets mapped to 1 in y equals to x square, but it cuts only once. So as you can see, the vertical line cuts only once. So it is a function. Now I am going to draw a circle of radius 1. So circle of radius 1 you know is x square plus y square equals to 1, and I am going to write it in a square root form. I am going to write it as y equals to square root of 1 minus x square. Now again, if you draw a vertical line, it cuts in 2 points. So the circle is not a function. So all these functions like fx equals to root x, y equals to square root of 1 minus x square, these are not functions, but we describe them by equations and therefore we call them implicit functions because they are not functions explicitly, and that's why they are called implicit functions. So these are not functions. Notice that the vertical line cuts in 2 points, and we said that it should cut in only 1 point as per the definition. Every element of set P has one and only one image in set Q. Or we can say every element of x-axis has one and only one image in y-axis. I want to give another example. Now I will just draw some arbitrary function without an equation. Now draw a vertical line. So now the vertical line cuts at many points. Yeah, let me draw these the points where it cuts in red. Say it cuts here, 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 here. So there are obviously more than one point where it cuts. So this is not a function. So such a test where you can draw a vertical line and see how many places it cuts is called a vertical line test.